Hi there, Chapter 4 notes. We're looking at regressions fitting lines to data. So when we've got our data, we can fit a regression line, which is a line of best fit. What this actually means is that we're fitting a line through our data that fits as close to all the data points as possible. So what a residual is the distance above or below this line of best fit. So our aim is that when we fit a regression line, that this line goes through all the data that minimizes this distance above and below. So these data points above and below. So a residual, as I said, is a vertical distance above or below this line of best fit. We can work out this residual value for each of these dot points by having our actual data point. So for example, our actual data point and minusing what is predicted. And where you get this predicted value from is when you've got your formula for your line of best fit. If you place in the x value, it will give you the y value. So minusing what that data actually is predicted. So actual data value minus the predicted value. Now when our regression line is fitted, a regression line will predict your RV value. So going back to Chapter 3 notes, knowing that your RV value is your Y value, it's your dependent value. So once again, have this somewhere. If you're not sure how to remember which one's RV and which one's EV, have this written somewhere. So regression line is predicting our RV value, which is your Y value. So we can work out our least squared regression line by using this formula here. So this is our y equals mx plus c formula, if you know it that way. However, we can work out what this b value, which is the gradient, and this a value, which is our y-intercept, we can work out those two values by using this formula here. These will be given to you. If they're not given to you, you can actually find out these values using your calculator. So sy and sx. These ones with the lines on the top, they're your means, and those were your standard deviations, and that's your R value. So you can calculate this formula from this information. They will generally give you this information. When writing equations, do not leave it as x and y. If you do, I'll be so angry. Use the variable names. I can tell you right now, your assessors will mark you wrong. If you leave it as y equals something x plus c, they're going to mark you wrong. Make sure you have the variable names, age and weight, height and whatever. Make sure you use those in your formula. Do not leave as y and x's in your formula. Hopefully you will remember that. Please do not go to all the effort to get the question right, but then at the end, getting it marked wrong. Y equals mx plus c, the value that's with your x is your gradient, the value on its own is your y-intercept. When reading your y-intercept from a graph, can you please double check, triple check that your x-axis starts at 0? As you can see here, it's a broken axis, so your y-axis is actually starting at 10 on the x-axis. So whatever value it may go through on this graph here, if they'll draw a line through here, is not your y-intercept, because that's only in line with 10. It would continue down to your x is 0. So double check that your x-axis starts at 0, please. Once again, I've placed it here as your dependent variable and independent variable, and then placed RV and EV on just to help identify which one's the response and explanatory variables. Residual plots, random with no pattern. So when you plot your residual plot, it's either going to have no pattern or it's going to have a pattern. So as we can see, it's a clear pattern here. If there is no pattern, the lack of clear pattern in the residual plot supports the assumption that the relationship between your dependent and independent, or your RV and your EV variables, is linear. So we are looking for no pattern to make it linear. If there is a pattern, we call into question if there actually is a linear relationship. Now, how do we get these residual plots? From your core SAC, quite a few people weren't able to actually do this. So I'm going to show you again. Plotting residual plots on your calculator here. There's a list, but I'm going to show you on your calculator. Okay, so in statistics, here's our data. We want to go to Calc, Regression, Linear Reg. Double check that your X and your Y variables in the right lists. And then over here, it's got Copy Residuals. I'm going to place that in list 3 because list 3 is blank. So we've got X and Y in list 1 and 2, and list 3 is blank. Go OK. There's your how you can work out your regression formula, your R and your R squared. Go OK and jump out. Places your graph there. Here's all our residual values here. Now, what we want to do is we want to go, we want to draw a graph. We want it to be scatter. We want our X list to be list 1. However, we want our Y list to be our residual values. So we're putting our Y list as list 3. Set and plot the graph using this button. Then all these data values come out on your axes. This is how far, these are your residuals, so how far they were from your line of best fit. So if your line of best fit, your regression line was horizontal, this is how it actually looks above and below your regression line. This then, you compare whatever comes up here, you compare it to up here. Is there a pattern or is there no pattern? That's how we decide whether there's a relationship, between a linear relationship. So go through, can you please have a look at this? Multiple choice exam, 100% there's going to be a residual plot question on that. It usually comes up in the multiple choice rather than the short answer exam. Interpreting a slope, once again, here is a template. Put that template in your resource booklet, word for word, whatever's in the brackets, change it to whatever the information is. And your IV, once again, knowing which one's your independent dependent variable, making sure we're using it as your response variable and explanatory variable. So I've left those as DV and IV just to help you out. Interpolation, we are predicting within the data range, and extrapolation, we predict when something's outside the data range. When we're looking at information, have a look. Is it in your data range? Can you actually see it? Are you predicting in the information that you've got, or are you over predicting? So something that might be extrapolation may be predicting in the future, something outside our range. So like year 2030. That's extrapolation. We're predicting outside our data. And when we're predicting something that's, say, outside our data, it's extrapolating, that can be an issue. We can't guarantee that that's going to be true. So if we're predicting inside our data, interpolation, we can say, yep, that's true. But if something's predicting outside our data, we can then say it's going to be called into question. So if a question's asking, is this data reliable? Make sure you use the words interpolation and extrapolation. The VCAA assessors, they're looking for you using those two words. So if something's asking, is this reliable prediction? Make sure you use extrapolation and interpolation. Thank you.